They shine brighter than 100 galaxies, but they are billions of light years away. This audiobook explores quasars, the most powerful galactic nuclei in the universe, where supermassive black holes devour matter and emit light that has travelled for eons to reach us. They are more than distant objects. They are windows to the cosmic past, beacons that show us what the universe was like when it was just beginning to light up. Imagine for a moment that you're in the darkest night, far from the city lights. You look up and find yourself surrounded by a blanket of stars. Some of these stars are part of our galaxy, but others are so far away that their light has travelled millions of years to reach us. Quasars are like those distant stars, but with an incomparable brightness. They are, in essence, the most luminous objects in the universe. The light from a quasar can be so intense that it surpasses that of thousands of galaxies combined. Can you imagine that? A single light source that could eclipse everything we know in our own galaxy. This is because quasars are the result of supermassive black holes devouring matter at incredible speeds, releasing energy in the form of light that we can detect even at unimaginable distances. But why should we care about them? The answer is simple. Quasars act as beacons in the darkness, guiding us through the vast ocean of space. They allow us to study how galaxies formed, how the universe evolves, and ultimately who we are in this vast cosmos. Without quasars, our understanding of the universe would be incomplete, like a puzzle without its most crucial pieces. Every time an astronomer observes a quasar, they are looking back in time. The light we see today could have left that quasar billions of years ago. In a sense, each quasar is a portal to the past, a window that shows us what the universe was like in its early days. And in doing so, it raises intriguing questions. What was the universe like when these powerful objects formed? What do they tell us about the nature of matter and energy? Quasars not only show us the past of the universe, but they also reveal its structure. By studying their light, scientists can better understand the distribution of dark matter and how galaxies cluster. Isn't it amazing to think that a small flash of light can contain so many clues about the cosmos? As we delve deeper into the study of quasars, we find that they are also related to the growth of galaxies. Quasars are a signal that something important is happening in their environment. When a supermassive black hole feeds, an explosion of energy occurs that can influence the formation of stars and the evolution of galaxies. It's as if quasars were the engines of galactic creation. Even more intriguing is the fact that quasars can help us understand the expansion of the universe. By observing how quasars are distributed in space and how their light shifts to red, we can gain valuable information about the speed at which the universe is expanding. This information is crucial to answering fundamental questions about the future of the universe. In addition, quasars are vital tools in the search for life on other planets. Their light can illuminate the conditions in which galaxies and planetary systems form. By studying quasars, we are also learning about the possibility of other habitable worlds existing in the cosmos. The story of quasars is a story of discovery. From their first sighting in the 1960s to the most recent research, we have come a long way in our understanding. Each new discovery about quasars brings us a little closer to understanding the universe in which we live. As we continue to explore and discover more about quasars, we also face many myths and misunderstandings. It is essential to debunk these erroneous beliefs to truly appreciate the nature of these fascinating objects. Quasars are not just strange phenomena, they are essential elements of our cosmos that deserve to be understood. At the end of the day, quasars are more than just bright lights in the sky. They are reminders of how little we know and how much we still have to discover. Each quasar we observe invites us to ask more about the universe, to explore its history, and to dream about what is beyond our reach. On this journey of exploration, quasars are our guides, illuminating the path to cosmic knowledge. So, are you ready to dive into the fascinating world of quasars? The adventure is just beginning. Quasars are one of the most fascinating phenomena in the universe. But what exactly are they? To understand, we first have to think of them as the brightest lights in a city, those that stand out on the horizon even from a distance. In the vast cosmos, quasars are the beacons that guide us to the farthest corners of space and time. But what makes them so special? At first glance, a quasar seems to be a star, but it is much more than that. They form around supermassive black holes, which are like huge cosmic vacuum cleaners, devouring matter around them. When this matter approaches the black hole, it heats up and emits an incredible amount of energy, sometimes thousands of times greater than that of an entire galaxy. So, when we look at a quasar, what we are seeing is the glow of this burning matter spinning at high speed before crossing the black hole's event horizon. Quasars are therefore a combination of two elements, a supermassive black hole and the disk of matter that surrounds it. This disk, filled with gas and dust, is what generates the intense light we observe from Earth. In a way, we could compare it to a lighthouse in the middle of the ocean's darkness, where the light helps us orient ourselves and understand the immensity that surrounds us. One of the most fascinating features of quasars is their distance. Many of them are so far away that their light has been travelling for billions of years to reach us. This means that when observing a quasar, we are not only seeing its light, but we are also looking into the past. Can you imagine? Every time we look at a quasar, we are looking at an era in the universe that has been trapped in the vastness of time. The luminosity of quasars is another intriguing aspect. Some are so bright that they can be seen from incredible distances, making them valuable tools for astronomers. By studying their light, we can learn about the composition of the universe and the structure of the galaxies that surround them. But what is behind that intense light? The answer lies in the energy released when material falls towards the black hole. The evolution of a quasar is a fascinating phenomenon. As the black hole consumes more matter, it can experience changes in its luminosity. Sometimes, a quasar can become brighter or dimmer, almost as if it were blinking. This behaviour gives us clues about the dynamics of black holes and the material that surrounds them. Each variation in its brightness is like a signal that sends us information about its environment. Moreover, quasars are not alone in the universe. Their study leads us to better understand the formation of galaxies. Quasars can influence the growth of the galaxies around them, acting as engines of change in the cosmos. Imagine a large engine in a factory. The more power it produces, the more influence it has on the environment around it. These cosmic wonders also offer us the opportunity to explore dark matter, that mysterious substance that makes up a large part of the universe, but we cannot see directly. Quasars can serve as beacons that illuminate the path to understanding this elusive matter. By observing how quasars are distributed in the cosmos, we can infer the presence of dark matter and how it affects the structure of the universe. One of the most intriguing questions is, how are quasars classified? Not all of them are the same. There are different types, each with unique characteristics that affect their luminosity and light spectrum. This diversity allows us to better understand the history of the universe and how different structures have formed over time. Quasars are also crucial for cosmology. Their light helps us measure the expansion of the universe and understand its history. Like a map guiding us through unknown terrain, quasars provide us with a vision of how the universe has changed over billions of years. This is especially important considering that the universe is constantly expanding. The key to studying quasars lies in the technology we use. With increasingly powerful telescopes, astronomers can observe these distant bodies and gather valuable data. The precision of modern tools allows us to have a clearer understanding of how they work and what secrets they hide. As we advance in our understanding of quasars, we face the fascinating possibility that they may impact the search for life on other planets. The light they emit can offer clues about the chemistry of planets orbiting distant stars. In a sense, quasars can be like messengers bringing us information about life in places we can't even imagine. Finally, it is important to reflect on the relevance of quasars in our quest for astronomical knowledge. These objects are not just points of light in the sky, but windows into the past and future of the universe. They show us not only what has been, but also what could be, and challenge us to continue exploring and questioning what we know about the cosmos. In each quasar, we find not just an object of study, but an invitation to discover the deepest mysteries of the universe. In the vastness of the universe, quasars emerge as some of the most fascinating and mysterious phenomena we have discovered. But what are they really? To understand their story, we must go back to the 1960s, when a group of astronomers began to notice something peculiar in the sky. They were observing certain light sources that did not seem to fit into the known categories of stars or galaxies. At that moment, curiosity was ignited. Could these lights be something completely new? Quasars are actually the cores of extremely distant galaxies, powered by supermassive black holes. But how did we come to this conclusion? The story begins with an unexpected discovery. Astronomers noticed that some of these objects were not only incredibly bright, but also exhibited spectral features that defied the understanding of the time. This raised an intriguing question. How is it possible for something so distant to emit so much light? At first, the scientific community was confused. These objects were thought to be very distant stars, but as more observations were made, surprising details were revealed. Quasars were not simple stars, but true energy factories at the heart of distant galaxies. How did they manage to be so powerful and bright? The answer lies in the material falling towards the supermassive black hole that resides at their center. This material, being attracted by gravity, heats up to extreme temperatures and emits huge amounts of radiation. To put this into perspective, imagine a huge vacuum cleaner that swallows everything around it. As objects approach the entrance of this vacuum cleaner, they accelerate and heat up, producing light and energy in the process. In the case of quasars, this heat translates into visible light and other forms of radiation, making them visible across billions of light years. The first time a quasar was identified was in 1963, when astronomer Martin Schmidt observed the object known as 3C273. This discovery not only opened the door to a new field of study, but also transformed our understanding of the universe. But what does this mean for us today? Quasars act as beacons, illuminating the darkness of space and allowing us to see beyond what we could imagine. Over time, more quasars were identified, and scientists began to classify them. They realized that not all are the same. Some are brighter than others, and their light can vary in intensity. This raises another question. What factors determine this variability? The answer has to do with the amount of material the black hole is absorbing and how the surrounding matter is structured. To understand the importance of quasars, it is essential to recognize that they are indicators of the early universe. They tell us stories about the conditions of the cosmos at times when galaxies were forming. By studying distant quasars, we can glimpse what the universe looked like just a billion years after the Big Bang. This is like looking through a window in time, where every ray of light we receive brings us information about the past. The search for quasars has also taught us about the expansion of the universe. By observing how the light from these objects shifts towards red, astronomers can calculate the speed at which they are moving away from us. This leads us to a fundamental question. What does this mean for the future of the universe? The answer is complex but also exciting. It helps us understand how the cosmos evolves. As quasars become more visible and new ones are discovered, the scientific community faces a constant challenge: understanding their role in galaxy formation. Some studies suggest that the activity of quasars can influence the growth and development of the galaxies that host them. This leads us to wonder: are quasars simply products of galactic evolution? Or are they also active agents in the formation of cosmic structures? The story of the discovery of quasars is therefore a mix of curiosity, observation, and an insatiable desire to unravel the mysteries of the universe. Each new discovery not only adds a piece to the puzzle, but also raises new questions. What other surprises await us in the vast universe as we continue to explore? The search for quasars is just the beginning, and their study could reveal much more than we still do not know. In short, these objects are not just distant lights in the sky. They are keys that help us unlock the doors of knowledge about the cosmos and our place in it. The energy of quasars is a truly fascinating phenomenon, almost like a mystery of the universe that invites us to explore. But what really drives this immense energy they emanate? To understand it, it is essential to delve into the heart of these astronomical objects, where supermassive black holes play a crucial role. Let's imagine for a moment that a quasar is like a gigantic lamp in the cosmos, illuminating the vast space around it. But this lamp does not light up by magic. There is a very specific process behind its brightness. At the core of a quasar lies a supermassive black hole. Now, what is a supermassive black hole? Think of it as a ravenous and thirsty monster that consumes everything that gets too close. This black hole has a mass that can be millions or even billions of times greater than that of the Sun. As matter, such as gas and dust, approaches the black hole, it begins to spin around it, forming what is known as an accretion disk. This disk is like a huge dance floor of cosmic material moving rapidly. The fascinating thing about this disk is that as matter approaches the black hole, it heats up to extreme temperatures due to friction and compression. Imagine being on a dance floor where everyone is moving so fast that they start to collide with each other, generating heat. Thus, the temperatures in the accretion disk can reach millions of degrees, causing the material to shine brightly. This is the first crucial step in creating the energy we see in the form of light and other radiations coming from the quasar. But how is all that thermal energy translated into the light we observe from Earth? As the material in the accretion disk heats up, it begins to emit radiation at different wavelengths. This includes everything from radio waves to X-rays, creating a spectrum of light that is incredibly powerful. Imagine that each quasar is like a cosmic beacon, emitting a light so intense that it can be seen across billions of light years away. This brightness is not only astonishing, but it also gives us clues about the processes occurring in the universe. One of the most intriguing questions is, why are some quasars brighter than others? The answer lies in the amount of material being devoured by the black hole. If a quasar has a massive accretion disk, it will be brighter because there is more matter being consumed and therefore more energy generated. On the other hand, if the black hole is devouring less material, its brightness will be lower. This leads us to think about the relationship between the consumption of matter and luminosity. The more food for the black hole, the brighter the quasar. In addition, quasars can also release huge jets of energy, known as jets. These jets are like two powerful hoses that shoot material at speeds close to that of light. Where does this energy come from? The jets are formed when part of the material in the accretion disk does not fall into the black hole but is expelled into space. This phenomenon is a reminder that even in the chaos of a quasar, there is order and structure in how energy is distributed. The energy of quasars is not only fascinating in terms of its origin, but also for what it reveals about the universe. By observing the light emitted by a quasar, astronomers can study not only the quasar itself, but also the environment surrounding it. For example, the light from a quasar can pass through clouds of gas and dust on its way to us, allowing us to analyze the composition of those materials. It's as if quasars were messengers of the cosmos, bringing us information about what lies between them and us. Another intriguing aspect is the relationship between quasars and the concept of time. The light we see today from a quasar may have been emitted billions of years ago. This means that by observing a quasar, we are not only seeing its light, but we are looking into the past. It's as if we had a cosmic time machine, allowing us to glimpse events that occurred at a time when the universe was very different. This ability to observe the past helps us better understand the evolution of the cosmos. The energy of quasars also raises questions about the structure of the universe. For example, how do quasars influence the formation of galaxies? It is believed that the energy they release can affect the growth of nearby galaxies and help shape the way stars and gas are distributed in space. Imagine that quasars are like large beacons that not only illuminate the way, but also influence the way communities develop around them. As scientists continue to investigate, the energy of quasars continues to reveal secrets about the nature of the universe. Each discovery brings us a little closer to understanding how the cosmos was formed and how it works. The energy of quasars is a reminder that, although the universe may seem vast and unknown, there are patterns and processes that we can unravel with curiosity and ingenuity. In summary, the energy of quasars is one of the most fascinating aspects of modern astronomy. From the inner workings of supermassive black holes to the impact they have on their surroundings, each quasar is a unique window to the past and present of the universe. As we continue to explore these cosmic beacons, each answer leads us to new questions, keeping the flame of human curiosity alive in our quest to understand the cosmos. Quasars are fascinating objects that have captured the attention of astronomers and universe enthusiasts alike. But what is their connection with black holes? Why are these cosmic giants fundamental to understanding the workings of quasars? To answer these questions, we first need to delve into the nature of these supermassive black holes. Imagine a black hole as a colossus at the center of a galaxy, a monster devouring matter. As matter approaches it, a disk of material forms around it, like a whirlpool in water. This process is similar to how a vortex forms when a bathtub is drained. The matter that accumulates in this disk heats up to extreme temperatures, generating radiation that shines brightly and becomes what we know as a quasar. A quasar, then, is a kind of cosmic beacon, emitting light and energy in unimaginable amounts. But what fuels this dazzling brightness? The answer lies in the veracity of the black hole. As the black hole consumes gas and dust, it releases an immense amount of energy in the form of electromagnetic radiation. This includes visible light, X-rays, and other forms of radiation that, when emitted with such force, can be seen from billions of light years away. This feeding process is akin to a bonfire that burns intensely when given more wood. The more fuel it has, the brighter and hotter it becomes. In the case of quasars, that fuel is the material falling towards the black hole. But how do we know that a quasar and a black hole are so intimately related? The answer lies in their characteristics. Quasars, like black holes, are incredibly massive. In fact, it is believed that the black holes at the centers of quasars can have masses ranging from millions to billions of times the mass of our Sun. This enormous gravity is what allows a quasar to shine so intensely. But what about quasars that are not active? Are there turned-off quasars? It is essential to understand that not all black holes are quasars. A black hole needs to be in a state of active feeding to become a quasar. This means it must be capturing enough material to generate that dazzling brightness. When the material is scarce, the quasar turns off and becomes a silent black hole, which is hard to detect until it captures matter again. How are these quasars formed in the first place? They are often found in the centers of galaxies that have experienced mergers or collisions with other galaxies. When this happens, gas and dust are pushed towards the galactic center, where the black hole can consume it, initiating the cycle of spectacular brightness. This process not only illuminates the quasar, but also affects the galaxy surrounding it. influencing its formation and evolution. Another intriguing aspect of this relationship is how quasars can serve as tools for studying the universe. Their light travels through space and on its way, interacts with the material it encounters. This interaction can reveal information about dark matter and the structure of the universe. Thus, quasars are not only beacons but also messengers of the cosmos. Think of quasars as beacons guiding lost navigators in the darkness of the ocean. They provide us with clues about the history of the universe, helping us identify how galaxies have formed over time. But like a beacon emitting light in the fog, their light can also be affected by the environment, making their study even more fascinating. The relationship between quasars and black holes also raises questions about the future of the universe. Will these black holes continue to feed and shine for billions of years? Or will all quasars eventually turn off, leaving behind a darker universe? These questions invite us to reflect on the life and death of celestial objects. The evolution of quasars and their connection with black holes also lead us to consider the role they play in the formation of large-scale structures in the cosmos. By releasing energy and matter, quasars can influence how galaxies are distributed, affecting the formation of new stars and planets. Thus, they are not only objects of interest in themselves, but are key players in the cosmic narrative. In summary, the relationship between quasars and supermassive black holes is a fundamental link that helps us understand not only quasars themselves, but also the history and evolution of the cosmos. These bright objects show us a constantly changing universe, where matter and energy intertwine in a cosmic dance. Undoubtedly, quasars are one of the wonders of the universe that invite us to continue exploring and unraveling the mysteries of space. The light of quasars is one of the most fascinating aspects of these extraordinary entities in the universe. But what makes this light so special? To understand it, we first need to think about how we perceive light in our own world. When we look at the stars on a clear night, what we are seeing is light that travelled thousands of years to reach us. In the case of quasars, that light has travelled even further, traversing vast distances and reaching us from the edge of the observable universe. The light of a quasar is not simply any flash. It's like a cosmic beacon sending us information about its nature and the environment surrounding it. But how do we know where this light comes from and what it tells us? Each quasar emits light at different wavelengths, creating what we call a spectrum. This spectrum is like a unique code that reveals the quasar's chemical composition, its temperature, and even its movement through space. By observing a quasar's light spectrum, astronomers can detect patterns that indicate the presence of elements like hydrogen, helium, and other metals. But why is it important to know a quasar's composition? Imagine you're deciphering an ancient message. Each element you find gives you clues about the history and evolution of the quasar, as well as the universe it inhabits. Each quasar tells its own story through the light it emits. One of the most intriguing features of quasar light is its intensity. In fact, they are some of the brightest objects in the universe. Have you ever wondered how they can be so bright? The answer lies in the enormous amount of energy they generate. When matter approaches the supermassive black hole at the center of a quasar, it heats to extreme temperatures, generating a huge amount of light and radiation. It's like lighting a bonfire with a pile of wood. At first it doesn't seem like much, but once it starts burning, the light and heat it emits are overwhelming. Quasar light also allows us to explore the universe on a timescale that seems almost magical. When we look at a quasar, we are seeing its light as it was billions of years ago. It's like looking at an old photo of a friend. Even though the picture was taken a long time ago, you can still recognize the person. This means that by studying quasars, we not only understand their present, but also their past and the history of the universe itself. An intriguing question is, how do the conditions of space affect the light we emit? The answer is fascinating. Quasar light can pass through different media in space, such as gas and dust, which can distort it or change its color. This is similar to when you look through a foggy glass. The image you see is not the same as the original. This phenomenon, known as redshift, allows us to understand how the universe is expanding. Why should we care about the color of a quasar's light? Each color gives us a clue about its distance and speed. If a quasar is moving away from us, its light shifts towards longer wavelengths at the red end of the spectrum. This effect is not only crucial for measuring distances in the universe, but also helps us understand its expansion, a key concept in modern cosmology. Now let's move on to a more exciting aspect: the variability of quasar light. Did you know that some quasars can change in brightness in a matter of days? This variability offers us a window into the internal dynamics of these objects. Imagine a lighthouse that blinks. Each flash could be a signal that something intense is happening inside. Perhaps a change in the amount of matter being devoured by the black hole. Fluctuations in a quasar's light can also reveal detail about its structure. For example, if a quasar suddenly lights up, it may indicate that new material has fallen towards the black hole, increasing the energy and, therefore, the luminosity. This behavior helps us understand not only what is happening in the quasar, but also how they feed and evolve. But quasar light not only tells us about themselves, it also acts as a tool to explore the space between them. When a quasar's light passes through galaxies and clusters of matter, it interacts with them and provides us with information about the distribution of dark matter in the universe. It's as if each ray of light were a scout informing us about what's in its path. In the broader context of the universe, quasar light helps us illuminate the shadows of the past. As we explore more quasars, we begin to build a map of how galaxies and structures in the universe have formed and evolved over billions of years. Each quasar becomes a piece of the cosmic puzzle, and by putting them together, we can begin to see a clearer picture of the universe's history. Quasar light is, without a doubt, a gift from the cosmos. It offers us a direct connection to the past, helps us understand dark matter and the expansion of the universe, and illuminates the dynamics of supermassive black holes. Each ray of light that reaches us is an invitation to explore and discover, and as long as we keep looking at the sky, quasars will continue to be our beacons in the darkness of space. Thus, quasar light not only teaches us about them, but also invites us to reflect on our place in the vast universe. Every time we observe a quasar, we are reminded that we are connected to a much larger story, a story that spans time and space and that there is still much to discover. Quasars are some of the most fascinating objects in the universe, and their study offers us a unique window into the cosmic past. But what do quasars tell us about the early universe? In this section, we will explore how these titans of light and energy help us understand what the cosmos was like billions of years ago. First, it is essential to understand that quasars are like distant beacons illuminating the darkness of space. Imagine you're in a deep, dark cave, where every spark of light reveals a little more about the cave's geology. Quasars do something similar, but instead of revealing the rocks of a cave, they show us what the first galaxies were like, and the conditions of the universe in its infancy. When we observe a quasar, we are actually seeing light that was emitted billions of years ago. Have you ever wondered what this means? It means that we are looking back in time to a time when the universe was very different from what we know today. Quasars formed when the universe was young, about 1 billion years after the Big Bang, at a time when matter and energy were grouping together to shape the first galaxies. By studying the light from a quasar, astronomers can infer many things about its environment. For example, the light reveals the chemical composition of the matter surrounding the quasar. It's as if you were reading a history book telling how the elements in the first stars were formed. Quasars, therefore, are invaluable sources of information about the chemistry of the early universe. But how do we know that these objects are so old? The answer lies in the distance. Quasars are located at unimaginable distances from Earth, and that distance translates into time. The further away an object is, the older it is. So by observing distant quasars, we are seeing the universe as it was billions of years ago. It's like watching a movie where each scene shows you a different moment from a distant past. Moreover, quasars are extremely bright. In fact, they are some of the brightest light sources we know. This is due to the enormous energy they release, as the supermassive black holes that feed them devour matter. This exceptional brightness allows quasars to be visible across astronomical distances. Imagine having a flashlight that shines with the intensity of millions of suns. That's the light quasars emit. Quasars also offer us clues about galaxy formation. These powerful light sources are believed to have played a crucial role in the evolution of the galaxies they reside in. As quasars shone and released energy, their influence shaped the environment around them, impacting the gas and dust of forming galaxies. This helps us understand how galaxies grew and evolved over time. The light from quasars allows us to study the structure of the early universe, and in doing so, scientists have made some surprising discoveries. For example, by analysing the light from distant quasars, we have been able to identify the presence of large amounts of hydrogen, which is the most abundant element in the universe. This finding suggests that the early universe was filled with this gas, which is fundamental for the formation of stars and galaxies. Additionally, quasars help astronomers map the distribution of matter in the universe. As the light from a quasar passes through space, it can be affected by the gravity of massive objects, such as nearby galaxies. This phenomenon, known as gravitational lensing, allows scientists to obtain information about the amount and distribution of dark matter in the universe, a substance we still don't fully understand. It's fascinating to think that by studying quasars, we're not only learning about the universe's past, but also about its future. By understanding how the first galaxies formed and evolved, we can make predictions about how galaxies might evolve in the future. It's like having a cosmic recipe book that teaches us not only to cook a dish, but also to innovate and create new recipes. Quasars also confront us with some of the deepest questions in cosmology. How did the structures of the universe develop? What conditions facilitated the formation of galaxies? Every discovery related to quasars brings us closer to answers that could change our understanding of the cosmos. The study of quasars is, in essence, a journey through time and space. Each quasar we observe is like a beacon guiding us through the vast darkness of the universe, illuminating the early stages of its history. By investigating these objects, we are not only exploring the nature of the universe, but also our own existence in it. In conclusion, quasars are much more than mere points of light in the sky. They are witnesses of the past, bearers of cosmic secrets, and powerful tools in the search for answers. As we continue to investigate and discover more about these enigmatic objects, each new finding brings us one step closer to unraveling the history of the universe, and ultimately, our place in it. There are different types of quasars, and each one reveals a fascinating aspect of the universe. But what distinguishes them from each other? To understand this, we first need to know the characteristics that classify quasars. What's amazing is that, although they are all extremely bright and are located at colossal distances, there are nuances that make them unique. Let's start with Type 1 and Type 2 quasars. Type 1 is like a glowing beacon, visible from vast distances. These quasars have a broad spectrum and are so luminous that they can be observed even billions of light years away. But what about Type 2 quasars? They are a bit more reserved. Their light is dimmer and they are often surrounded by clouds of gas and dust that hide their brightness. This phenomenon is due to their light being partially blocked. The difference between both types is similar to the way we see a lighthouse on a clear night versus how we would see it if it were wrapped in thick fog. And what about radio quasars? These are a special group that emits powerful radio waves. Radio quasars are like a cosmic megaphone, amplifying their presence in the universe. They are especially interesting because their radio emission gives us clues about the processes occurring in their cores. Most quasars do not emit radio waves, but those that do offer astronomers a unique opportunity to study the matter surrounding them and how they interact with their environment. Another intriguing aspect is the variability in quasars' luminosity. Why do some shine intensely for short periods and then fade? This variation may be an indication that something unusual is happening in their core. Perhaps a jet of gas is moving at high speed, or maybe there are changes in the amount of matter falling into the supermassive black hole that feeds it. This dance of light and shadow gives us a deeper insight into these celestial bodies, and each flash is a story to tell. Quasars can also be classified according to their distance. Nearby quasars are like next-door neighbours, while the farthest ones are like echoes of a very distant past. Studying quasars at different distances is crucial, as it allows us to observe not only the evolution of these objects over time, but also how the universe as a whole has changed. Each distant quasar is a window to a moment in time, offering a view of the universe as it was billions of years ago. The mass of the black hole feeding a quasar is also a factor that helps classify them. Some quasars have supermassive black holes that weigh billions of times the mass of the Sun, while others are a bit more modest in comparison. This difference in mass can influence how the quasar behaves, from the amount of energy it emits to the way it interacts with its galactic environment. In the field of astrobiology, the classification of quasars can also be relevant. Some astronomers wonder how the intense radiation from quasars can affect planets in nearby galaxies. For example, could the light from a quasar alter the chemistry of an exoplanet's atmosphere? It's an intriguing question that opens a new field of study on how life could develop in extreme environments. We cannot forget the quasars that are in the process of becoming something different. Some astronomers have observed that certain quasars are transient, meaning they could eventually turn off and transform into more conventional galaxies. This process of change shows us that the universe is dynamic, and that even the brightest objects have a life cycle. The classification of quasars does not stop at their shape or size. The way they interact with other galaxies is also an important aspect. Some quasars appear to be at the center of galactic interactions, where gravitational forces shape their behavior. Observing how these encounters affect quasars can provide us with valuable information about galactic evolution. Some quasars also present a phenomenon known as twin quasars. This phenomenon occurs when two quasars are so close to each other that they appear to be a single object. This type of quasar is a treasure for astronomers, as it provides a unique opportunity to study the light from two quasars simultaneously and understand how they form and evolve in the context of their environment. The classification of quasars is a constantly evolving field. As technology advances and new observation techniques are developed, astronomers are discovering more about these fascinating objects. Each new discovery brings us a little closer to understanding how they form, how they interact, and how they influence the universe around us. In summary, quasars are much more than simple bright points in the sky. Their classification and variety tell us complex stories about the universe, its history, and its evolution. From Type 1 and 2 quasars to radio quasars and transient phenomena, each one offers a unique perspective that helps us unravel the mysteries of the cosmos. So, the next time you look up at the sky, remember that those bright beacons of the universe have a lot to reveal to us about the vast and intriguing world we inhabit. The light from quasars is like an echo from the past, a whisper of events that occurred billions of years ago. Each flash we see in the sky tells us a story that traveled through the vast universe before reaching our eyes. But what does this really mean? Why is the light from quasars so special, and what does it reveal about the universe we live in? First, it's important to understand that the light from a quasar is not just light, it's a window to the past. When we observe a quasar, we are seeing what happened at a time when the universe was very different from what we know today. The light we receive from these distant objects may have been emitted when the first galaxies were forming, which means that each quasar we see is like a time capsule, taking us back to the early stages of the cosmos's existence. But how is it possible that we can see something so far away? Imagine you're at a huge concert and there's a massive crowd. When someone on the stage throws some light towards the audience, that light travels through the crowd, passing through heads and arms until it finally reaches your eyes. In this analogy, the quasar is the stage, and the light it emits has to travel through all of space and time to reach us. The distance it travels is so immense that often, the light we see today tells us stories from billions of years ago. The light from quasars is also extremely powerful. In fact, they can be up to 1,000 times brighter than all the stars in a galaxy combined. This is due to the enormous amount of energy generated by their supermassive black holes. Can you imagine how much energy it takes to light a lighthouse that shines with such intensity? That energy comes from matter falling towards the black hole, forming an accretion disk that emits light in different wavelengths, from radio to X-rays. Now let's think about the spectrum of light that quasars emit. This spectrum is like a unique fingerprint. Each quasar has its own color pattern that reveals information about its composition, temperature, and speed. For example, if we observe a quasar and notice certain lines in its spectrum, we can deduce what chemical elements are present and at what speed it is moving. This play of light and shadow is crucial for astronomers who use light as a tool to explore the universe. One of the most fascinating things about the light from quasars is that as it travels through space, it can be affected by the gravity of other celestial bodies. This is known as gravitational lensing. Imagine you're watching a movie and suddenly the image distorts. That's what happens when the light from a quasar passes close to a massive galaxy. That galaxy acts as a lens, amplifying and distorting the quasar's light, allowing scientists to study not only the quasar but also the galaxy causing the distortion. What can we learn from the light from quasars about the expansion of the universe? When we observe quasars at different distances, we notice that their light shifts towards red. This phenomenon is known as redshift and is clear evidence that the universe is expanding. Just like the sound of a train moving away, the light from quasars stretches in wavelength as the universe expands. This helps us understand not only the speed at which it is expanding, but also the very history of the cosmos. The light from quasars not only tells us about the past, but it also allows us to map the structure of the universe. By observing the distribution of quasars in space, astronomers can identify large cosmic structures such as clusters of galaxies and filaments of dark matter. These observations are like a star map guiding us through the vastness of the universe. But what about the most distant quasars? Every time we discover a more distant quasar, we are looking further back in time. This means we can study what the universe was like in its infancy, offering clues about the formation of galaxies and the evolution of the cosmos. It's as if we're using a time machine, where each quasar is a different destination. However, not everything is simple. As the light from quasars travels, it can interact with the intergalactic medium, which can alter its signature. That's why scientists must be careful when interpreting the data. Each quasar is a puzzle, and each piece of light is a clue that helps us solve it. The light from quasars also challenges our conceptions about physics. By studying these extreme objects, scientists are pushing the boundaries of our understanding of how the universe works. They make us question the laws we thought we knew and lead us to explore new theories that could revolutionize our view of the cosmos. But what does this mean for us, ordinary people? Research on quasars is not only fascinating from a scientific point of view, but it also connects us with the universe. It reminds us that we are part of something much bigger, that every star we see in the sky has a story to tell. The light from quasars invites us to look up and wonder about our place in this vast cosmic ocean. In the end, the light from quasars is a reminder that, although the universe is immense and complex, each flash we see is a signal that there is still much to discover. It encourages us to keep exploring, to keep asking, and to keep marveling at the wonders of the cosmos. The quest for answers unites us and drives us towards a future full of possibilities, where each quasar we discover will illuminate our path through the universe even more. Have you ever looked up at the sky and wondered how scientists manage to observe something as distant as a quasar? The answer lies in the tools they use, which are true cosmic eyes. Telescopes have been fundamental in this process, but they are not the only thing used. Just like a detective who needs various tools to solve a mystery, astronomers have a variety of instruments to study these distant and fascinating objects. Optical telescopes are perhaps the most well-known. They resemble large cameras that capture the light from celestial objects. But did you know they don't just observe visible light? Some telescopes are capable of capturing radiation at other wavelengths, such as infrared and ultraviolet. This is crucial, as quasars emit light across a wide range of frequencies, some of which are invisible to the eye. Just as a flashlight can illuminate a dark path, these telescopes illuminate the universe, revealing details that would otherwise remain hidden. A fascinating example is the Hubble Space Telescope. Imagine a satellite floating in space, far from the atmosphere that distorts light. This telescope has provided astonishing images of quasars, allowing scientists to study their structure and composition. But what happens when quasars are in regions of the spectrum that cannot be observed with optical telescopes? This is where other types of telescopes, such as radio telescopes, come into play. Radio telescopes are like huge antennas that capture radio waves emitted by quasars. These telescopes can detect signals that are invisible to our eyes, similar to how a radio can tune into different music stations. Thanks to these tools, astronomers have been able to map the universe in ways that were previously unimaginable. Thus, they have discovered that many quasars have very complex structures, like jets of material extending great distances. But what about spectrometers? These devices are like the magic wands of astronomers. They are used to break down light into its different colors, creating a spectrum. Why is this so important? Because each chemical element emits and absorbs light at specific wavelengths. By analyzing the spectrum of a quasar, scientists can determine its chemical composition. Imagine opening a cookbook and discovering what ingredients were used just by looking at the photos. That's how astronomers can read the history of a quasar. The combination of different tools allows scientists to get a more complete picture of quasars. Each telescope and spectrometer contributes a piece to the cosmic puzzle. But what about modern technology? artificial intelligence and machine learning are beginning to play a vital role in this quest. These technologies can analyze large volumes of data in the blink of an eye, something that would take humans a long time. Imagine having an assistant who can read 1,000 books in an instant and extract the most relevant information. That's what these tools do in the study of quasars. In addition, astronomers also use computer simulations to better understand the behavior of quasars. These simulations are like video games that represent how quasars behave under different conditions. By observing how they interact with their environment, scientists can formulate theories about how they form and evolve. It's like having a cosmic laboratory where you can experiment without having to travel millions of light years. X-ray telescopes are another key piece of the puzzle. These telescopes are capable of detecting the high-energy radiation emitted by quasars. Just like a metal detector that can find objects hidden under the ground, these telescopes can uncover the deepest secrets of quasars. The information they obtain is essential for understanding how supermassive black holes that feed quasars are fed. As technology advances, so do the tools that astronomers use. New telescopes, such as the 30-meter telescope, promise to revolutionize the study of quasars. These instruments offer unprecedented resolution and the ability to observe fainter objects than ever before. Imagine having a zoom so powerful that you can see the texture of a mountain from thousands of kilometers away. That's the promise of the new generation of telescopes. Collaboration between scientists from all over the world is also essential. The data collected by different telescopes is shared and combined, creating a more complete picture of quasars. This joint work is like an orchestra, where each musician plays their part, but together they create an impressive symphony. Thanks to this collaboration, discoveries have been made that were previously thought impossible. Finally, have you ever wondered how advances in communication technology have influenced the study of quasars? The ability to transmit data at high speed allows scientists to share information in real time. This means that a discovery in one country can be analyzed and discussed almost instantly in another part of the world. This has accelerated the pace of research and has allowed for amazing discoveries to be made in record time. As we explore the universe, the tools we use are becoming more sophisticated. Each technological advance brings us one step closer to unveiling the secrets of quasars and the cosmos in general. With each new discovery, a new window to the universe opens, and our quasars continue to be beacons that illuminate our path in this vast and mysterious darkness of space. Human curiosity, combined with technology, takes us on an endless journey towards knowledge. Quasars have fascinated astronomers since their discovery. But did you know they can also provide valuable clues about dark matter in the universe? Dark matter is one of the greatest mysteries of modern cosmology. Even though we can't see or touch it, it is believed to make up about 95% of the universe. Amazing, right? But how do quasars fit into this cosmic mystery? First, let's imagine the universe as a huge puzzle, and dark matter is one of the missing pieces. Quasars, those bright beacons in space, can help us understand where these pieces fit. When we observe a quasar, We are not only seeing intense light coming from a supermassive black hole, but we are also seeing how it interacts with the dark matter surrounding it. Does it sound complicated? Let's break it down. Quasars emit light that travels billions of years to reach us. During that journey, that light can be altered by dark matter. This phenomenon is called gravitational lensing. It's like you're looking through a window with smudges. The light from the quasar can be distorted as it passes through dark matter, giving us clues about the amount and distribution of this mysterious substance. Isn't it fascinating how something we can't see can influence what we do see? Now let's talk about how quasars can help us map the universe. When astronomers observe the light from a quasar, they can analyze its spectrum, which is like a fingerprint of the light. This spectrum reveals information about the chemical composition of the quasar and about the dark matter surrounding it. Essentially, quasars act as beacons that illuminate the shadows of the universe, revealing the presence of dark matter in regions where it was previously invisible. Imagine you're trying to read a book in a dark room. Suddenly someone turns on a flashlight. The light allows you to see details you couldn't have noticed before. That's how quasars work. They illuminate the cosmic surroundings, allowing us to see dark matter that would otherwise remain hidden. This process not only helps us understand the distribution of dark matter, but also gives us clues about how the structures of the universe, such as galaxies and galaxy clusters, were formed. Did you know that dark matter doesn't behave like normal matter? While objects we know, like planets and stars, interact through electromagnetic forces, dark matter only interacts through gravity. This means that even though it's everywhere, we can't detect it directly. However, quasars allow us to glimpse its gravitational influence. This raises the question, how can we be so sure that dark matter exists if we've never seen it? The answer lies in how astronomers have observed the movement of galaxies. When we look at how galaxies move in a cluster, we notice that there's more mass present than we can see. It's as if they were orbiting around a large invisible sphere. Quasars, being so bright, help us study these movements through time and space. In doing so, they reveal the existence of that hidden mass we think was dark matter. Moving on to an exciting aspect, dark matter could also be influencing the formation of the quasars themselves. As galaxies form and evolve, dark matter plays a crucial role in the accumulation of gas and dust that will eventually feed the supermassive black holes. So we could think that quasars are, in a way, the result of the interaction between normal matter and dark matter. It's a fascinating cycle. The search for new quasars has allowed scientists to gather more data about dark matter. The more quasars we discover, the more clues we will have about how it is distributed and how it affects the structure of the universe. But we're not just talking about finding more quasars. We're talking about unraveling one of the greatest mysteries of the cosmos. What secrets will these distant beacons reveal in the future? The relationship between quasars and dark matter also leads us to question how gravity behaves on cosmic scales. Could there be forms of matter and energy that we haven't discovered yet? Quasars could be the key to opening new doors in our understanding of physics. Every new discovery brings us one step closer to unveiling the nature of the universe. Some scientists believe that by studying quasars, we could even find answers to questions about the expansion of the universe. Is it accelerating due to dark energy, or does dark matter play a more important role than we think? Each observed quasar brings with it a new opportunity to investigate these fundamental questions. The connection between quasars and dark matter is a perfect example of how the universe is an interconnected place. What happens in a distant corner of the cosmos can provide crucial clues about what happens in another. Thus, quasars are not only beacons of light, they are also bridges to understanding the very nature of the universe. At the end of the day, even though dark matter remains a mystery, exploring its relationship with quasars allows us to dream about what is yet to be discovered. In each flash of light coming from a quasar, there is a story waiting to be told, a story that could redefine our understanding of the cosmos. And so, the search continues, driven by human curiosity and the eternal need to understand the universe around us. Quasars are like beacons in the vastness of the universe, illuminating paths that allow us to understand how it expands. But what does it really mean that they help measure this expansion? It's a fascinating concept that may seem complicated, but with a little imagination, everything becomes clearer. Imagine that the universe is an inflating balloon. As air is blown into the balloon, the points drawn on its surface move away from each other. Similarly, galaxies, including quasars, are moving away from each other. This expansion is what astronomers have been trying to decipher for decades. One of the most exciting methods to measure this expansion is through the light emitted by quasars. But why is the light from these distant objects so special? Each quasar emits an immense amount of energy, making them visible even at unimaginable distances. The light from a quasar can take billions of years to reach us, which means we are seeing the universe as it was eons ago. In a way, by observing a quasar, we are looking into the past, which offers us a unique window to understand how the universe has changed over time. The relationship between quasars and the expansion of the universe is based on the interpretation of a phenomenon called redshift. This phenomenon occurs when the light from an object shifts to longer wavelengths, indicating that the object is moving away from us. It's like you're listening to an ambulance siren that's moving away. As it moves away, the sound becomes lower. In the case of quasars, their light shifts to red, indicating that they are moving away at incredible speeds. This redshift provides us with crucial information about the speed at which the universe is expanding. Astronomers have used quasars as tools to measure distances in the cosmos. By knowing the speed at which they are moving away, we can go back in time and calculate what the universe was like at different epochs. This is fundamental to understanding cosmic history and how the structures we see today have formed. Therefore, quasars are not just distant objects, they are indicators of how the universe has evolved over billions of years. Imagine each quasar as a streetlight on a dark road. Each time we see one of these lights, we can determine how far away it is, and at the same time, understand the speed at which it is moving away. By grouping data from multiple quasars, scientists can create a map of the universe's expansion. This map helps us visualize how galaxies are distributed, and how dark matter and dark energy influence this expansion. Dark energy is an intriguing concept that has captured scientists' attention. This mysterious force is believed to be responsible for the acceleration of the universe's expansion. By studying quasars and their light, astronomers can gain clues about the nature of dark energy. It's as if quasars are messengers bringing information about one of the greatest mysteries of the cosmos. As we advance in understanding quasars and the expansion of the universe, even deeper questions arise. What will happen to the universe in the future? Some scientists suggest that if the expansion continues to accelerate, we could face a fate where galaxies move so far away that they become invisible to each other. This scenario, known as the Big Rip, is a fascinating possibility that invites us to reflect on the final fate of the cosmos. Research on quasars and their relationship with the expansion of the universe continues. Each discovery brings us a little closer to unraveling the secrets of the cosmos. What new surprises will the future hold? The search for answers is an exciting journey that combines human curiosity with the exploration of the universe. The next time you look at the sky and see a bright star, remember that it may not be a star at all, but a distant quasar, a beacon that speaks to us of a time and space in constant change. By studying these extraordinary objects, we are not only learning about the past, but also about the future of the universe. The role of quasars in cosmology is crucial, and their study provides us with tools to navigate the vastness of space. They teach us that the universe is a dynamic place, constantly changing. Each quasar reminds us that science is constantly evolving, and that each answer generates new questions. At the end of the day, quasars are more than just points of light in the sky. They are symbols of our quest for knowledge. They inspire us to look beyond the known and marvel at the grandeur of the universe. Human curiosity is a powerful engine that drives us to keep exploring, and quasars are one of the many wonders that guide us on this endless journey. The relationship between quasars and the evolution of galaxies is a fascinating topic that invites us to explore how these extraordinary objects influence the cosmos. What role do quasars play in the formation and transformation of galaxies? To understand this, we must first remember that quasars are essentially the bright cores of galaxies that harbour supermassive black holes. But what does this mean for galactic evolution? When a quasar activates, its light can be so intense that it can eclipse the light of the entire galaxy that surrounds it. Imagine a bright beacon in the middle of darkness. This beacon not only illuminates its surroundings, but can also influence what happens around it. The energy emanating from a quasar is capable of heating the gas and dust in the surrounding galaxy, which can trigger or inhibit the formation of new stars. So, can we think of quasars as architects of the universe? The interaction between the quasar and its mother galaxy is a cosmic dance. When the black hole at the centre of the galaxy feeds on matter, it emits huge amounts of energy. This energy not only disperses, but can also push material out, creating galactic winds. These winds are like gusts of wind that can sweep away the gas that could have turned into stars. Thus, a quasar not only illuminates, but can also decide the fate of its galaxy. But what happens when a quasar turns off? It's an intriguing phenomenon that leads us to think about the life cycle of galaxies. When the black hole stops attracting matter, the intense light of the quasar disappears. This can lead to a quiet galaxy where stars continue to form at a more leisurely pace. In this sense, quasars are like beacons that turn on and off, marking stages in the evolution of galaxies. The formation of quasars is intimately linked to the age of the universe. In the first billion years after the Big Bang, conditions were perfect for the formation of quasars. Galaxies were denser, and gas was abundant. This led to increased activity in galactic cores, where supermassive black holes began to grow rapidly. So, could it be said that quasars are the remnants of a vibrant period in the history of the universe? As the universe expands and evolves, the activity of quasars also changes. Currently, we observe fewer active quasars than in the past. This raises questions about the future of galaxies that were once bright beacons. Will they remain in the dark, or will they have new stages of activity? The answer to that question could be in the dynamics of dark matter, which influences the formation and evolution of galactic structures. Quasars are also valuable tools for astronomers looking to understand the universe's past. By studying the light emanating from these objects, details about the evolution of galaxies and the distribution of matter in the cosmos can be inferred. Each quasar is a journey back in time, revealing not only its own history but also that of the galaxies that surround it. What secrets do these ancient lights hold on their journey through the universe? Differences between quasars can provide clues about the diversity of galaxies. Some quasars are brighter than others, suggesting variations in the amount of matter their black hole is consuming. This leads us to think about how many different stories quasars can tell about their galactic environment. Each one, with its unique light, reflects a different chapter in cosmic history. In the interaction between quasars and galaxies, we find an example of how the universe is interconnected. Galaxies are not solitary islands, but are in constant interaction and change. Quasars, as indicators of this dynamic, allow us to see how the forces acting in the universe can shape and transform its structure. So, what other mysteries could these bright objects unveil? The study of quasars also confronts us with questions about the nature of dark matter. This mysterious form of matter, which does not emit light, is believed to play a crucial role in the formation of galaxies and quasars. The relationship between both is still an active field of research. Could it be that quasars are, in some way, a reflection of the influence of dark matter in the universe? As we continue to explore the cosmos, the evolution of galaxies and quasars remains a topic of great interest. Advances in technology and telescopes allow us to observe more quasars and, therefore, learn more about their impact on galactic formation. Each discovery brings us a little closer to understanding how these powerful cosmic beacons have shaped the universe as we know it. The story of quasars is ultimately a story of transformation. From their formation in the early days of the universe to their role in the evolution of galaxies, quasars are witnesses to cosmic history. With each new finding, a door opens to new questions and mysteries, reminding us that there is much more to discover in the vast universe. What new revelations await us in the future? The connection between quasars and galaxies invites us to reflect on our place in the universe. Just as quasars illuminate the sky, Our own explorations can bring light to the darkness of human knowledge. In this quest to understand the cosmos, quasars are not only beacons of light but also of hope and curiosity. The variability of quasars is a fascinating topic that sparks the curiosity of astronomers and enthusiasts alike. Why do they shine so intensely at times and seem to fade at others? This fluctuation in the brightness of quasars has puzzled scientists for decades, and to understand it, we must delve into the heart of these distant beacons of the universe. Firstly, it is essential to understand that quasars are not static objects. Just like a lighthouse on the coast that flickers with its light, quasars undergo changes in their brightness due to various reasons. But what factors influence this variability? One of the main causes is the interaction between the supermassive black hole that feeds the quasar and the material that orbits around it. This material, made up of gas and dust, rushes towards the black hole, creating an accretion disk. As the material gets closer to the black hole, it heats up to extreme temperatures, generating dazzling luminosity. Imagine a pot of boiling water. When the water starts to bubble, the bubbles formed at the bottom rise to the surface and burst. Something similar happens in the accretion disk of a quasar. Sometimes, there is a sudden increase in the amount of material falling towards the black hole, which causes an increase in the quasar's brightness. Conversely, if the input of material slows down, the brightness may decrease. This phenomenon can occur on timescales ranging from days to years, making the study of variability an exciting challenge. Astronomers have managed to measure this variability using telescopes that observe over time. Through these observations, they have found that some quasars can change their brightness in a matter of hours. This behavior has led to intriguing questions. What does this mean about the internal structure of a quasar? Could it be that they have different components that respond to the input of material differently? The answers to these questions are at the heart of current research. A particularly interesting aspect of variability is that not all quasars shine uniformly. Some show a regular pattern of change, while others seem to be more erratic. This has led scientists to classify quasars into different types, based on how and when they vary their brightness. For example, there are quasars that show brightness cycles that repeat every few months, while others may experience unexpected changes. This diversity is indicative of the complexity of the environment around each quasar. Variability also offers clues about distance and time. By observing how a quasar's brightness changes, astronomers can infer how far away it is and how much time has passed since it emitted that light. Thus, by studying the light that reaches us from a quasar, we are not only seeing a distant object, but we are also glimpsing the history of the universe. Each flash of light we observe is like an echo of events that occurred billions of years ago. Moreover, the variability in the brightness of quasars is not just a curiosity, it has also become a valuable tool in cosmology. Scientists can use these changes to measure the expansion of the universe and better understand its evolution. Thus, quasars are not only beacons that illuminate the cosmos, but they are also compasses that guide us in the complexity of space-time. However, the variability of quasars raises more questions than answers. What happens when a quasar completely turns off? Is it possible that some quasars stop shining and become inert objects? These are questions that astronomers continue to investigate, as the disappearance of a quasar could provide crucial information about the life cycles of these phenomena. Advancing in our understanding, it is crucial to mention how this variability affects our perception of quasars. Changes in their brightness can influence observations and therefore the theories we develop about the universe. For example, if a quasar appears to have turned off, it might be easy to assume that it has ceased to exist, but it could actually be in a phase of low activity. Research on the variability of quasars also opens up a panorama of collaboration between different scientific disciplines. Astronomers, physicists, and mathematicians come together to create models that explain these phenomena, analyzing data from multiple sources and telescopes. This synergy not only enriches our understanding of quasars, but it also reinforces the idea that the universe is an interconnected place, where each discovery can illuminate other aspects of knowledge. This study of the variability of quasars is an exciting journey that continues to reveal secrets of the cosmos. As technology advances and telescopes become more powerful, we are likely to discover even more surprises about these intriguing objects. Variability is just one of the many facets that make quasars such a dynamic and captivating field of study. In summary, the variability of quasars is a reflection of the complexity of the universe. Each change in their brightness is a story told through time and space, a narrative that connects us with the events that shaped our cosmos. As we continue to explore, we realize that quasars are much more than simple points of light. They are witnesses of the past and guides for our future in the pursuit of astronomical knowledge. Did you know that quasars are like cosmic beacons that illuminate the darkest corners of the universe? But how is it possible that these distant objects help us understand the secrets of the cosmos? Over the years, astronomers have discovered that quasars are more than just lights in the sky. They are powerful tools for measuring distances and understanding astronomical phenomena. Quasars emit enormous amounts of energy, which can be thousands of times brighter than an entire galaxy. But where does all that energy come from? Imagine a supermassive black hole acting like a giant magnet. Around this black hole, there is a disk of gas and dust that heats up as it approaches its destination. This friction generates intense radiation, the same that we see from Earth as the light of a quasar. So, in a way, quasars are the result of the cosmic dance between matter and gravity. As scientists have studied these objects, they have realized that they are not only sources of light, but also like cosmic clocks. Have you ever wondered how we can measure distance in the vast universe? This is where quasars come into play. Their light travels for billions of years to reach us, and with it, they bring information about their origin and the space they have crossed. By observing how much this light is red-shifted, astronomers can calculate how fast these objects are moving away from us. It's like receiving a letter from a friend who lives in another distant city, where time and distance seem to play in their favor. In addition, quasars tell us stories about the evolution of the universe. Isn't it fantastic to think that we can look back in time while observing these bright lights? When we see a quasar, we are seeing the light that left it when the universe was much younger. This information helps us understand how the first galaxies formed and how they have evolved over time. They are like time capsules that allow us to explore the cosmic past. While quasars are amazing, they also raise intriguing questions. Why are there so many quasars in the universe? Astronomers have found that most of the quasars we observe are in early stages of their life. This means they are in the process of growing and evolving. They are like young cosmic titans on the path to becoming full galaxies. This growth is largely driven by matter falling into the black hole, feeding it and making it shine with incredible intensity. However, research on quasars does not stop here. Scientists are constantly looking for new quasars, trying to understand how they are distributed in the universe and what they reveal about dark matter. Dark matter, which makes up a large part of the universe but we cannot see, interacts in mysterious ways with quasars. By studying how quasars are affected by the dark matter surrounding them, astronomers can get clues about its nature and behavior. The more we learn about quasars, the more questions arise. What other secrets do they hold? Could they be tools for investigating the expansion of the universe? By observing the light from quasars, scientists can measure how the universe is expanding, and in turn better understand the final destiny of our own galaxy. Thus, quasars are not only fascinating objects, but they are also key to unraveling the complexities of the cosmos. As we look to the future, research on quasars becomes increasingly exciting. New telescope technologies and observatories are being developed, which will allow scientists to discover even more distant and ancient quasars. This could open the door to new discoveries about the early stages of the universe and the formation of galactic structures. Human curiosity has led us to explore the universe beyond what we could have imagined. Quasars, with their bright light and mysterious nature, are a clear example of how science and exploration allow us to better understand our place in the cosmos. Each new quasar discovered is a step closer to answering questions that have fascinated humanity for centuries. At the end of the day, quasars are much more than simple points of light in the sky. They are silent witnesses to the history of the universe, and every time we observe one, we connect with the vast network of time and space that surrounds us. So, the next time you look up at the starry sky, remember that each light could be a quasar, a beacon guiding astronomers in their quest for knowledge. Who knows what mysteries still await us to discover? Quasars have captured the imagination of astronomers and the curious alike, but what do we really know about them? There are many myths and realities surrounding these fascinating celestial objects. Some see them as bright lights in the vast cosmos, while others believe they are mysterious and dangerous phenomena. What is truth and what is fiction? Let's unravel these misconceptions. Firstly, one of the most common myths is that quasars are stars. However, this couldn't be further from the truth. Although they are extremely bright, quasars are actually active galactic nuclei powered by supermassive black holes. Their brightness does not come from a nuclear reaction like a star's, but from matter falling towards the black hole and heating to incredibly high temperatures. So, if you ever thought a quasar was a star, it's time to correct that perception. Another popular myth is that quasars are close to us in the universe, but the reality is that they are billions of light years away. When we observe a quasar, we are actually looking into the past to a time when the universe was very different. This concept of looking back in time can be disconcerting, but it is one of the wonders of studying quasars. By observing their light, we can learn about the conditions of the universe in its early stages. Let's talk about the energy of quasars. Many people believe their light comes from a massive explosion. However, this is also a misunderstanding. The light from a quasar is not the result of a sudden explosion, but of a continuous process of matter accumulation. When a supermassive black hole draws in gas and dust from its host galaxy, this material heats up as it approaches the black hole, generating an immense amount of energy and light. This is like a beacon shining brightly in the darkness of space. An intriguing question is whether quasars are dangerous. The answer is a bit complicated. By themselves, quasars pose no threat to us on Earth. However, their enormous energy can influence their galactic environment. For example, the radiation emitted by a quasar can affect star formation in its galaxy. It's as if a quasar is a forest fire that can change the landscape around it, but it cannot cross the ocean to reach us. There are also myths about the number of quasars in the universe. Some people think they are extremely rare. However, astronomers have identified thousands of quasars in the observable universe. Although it may seem like they are scattered, they are actually a significant part of the population of active galactic nuclei. So, although they may seem scarce, they are actually more common than you might imagine. Let's move on to another myth. The idea that all quasars are the same. In reality, there is a surprising variety of quasars, each with unique characteristics. Some are brighter and more active than others, and these different types can give us clues about how a galaxy evolves over time. It's as if each quasar is a chapter in the universe's history, with its own narrative and lessons to teach us. Confusion can also arise when talking about the relationship between quasars and black holes. Some think that quasars are the same type of object as black holes, but this is not correct. While a black hole is a point of no return in space, a quasar is the result of the black hole's activity. It's like comparing an engine with the car it drives. One cannot exist without the other, but they are distinct in their function and form. The light from quasars can be misleading. Many people believe the light is uniform, but in reality quasars can show variations in their brightness. This variability can be a clue about what is happening near the black hole and the dynamics of the matter surrounding it. The flickering light of a quasar can be like the signal of a changing lighthouse, indicating that there is much more happening in its core than we can see with the eye. Sometimes quasars are associated with the creation of life elsewhere in the universe. But is this possible? Although quasars are bright and energetic, their intense radiation could be harmful to life as we know it. However, they could also play a role in galaxy formation and in the creation of the elements necessary for life. Thus, quasars may be actors in the story of the cosmos, but they are not necessarily friends of life. Finally, it is important to consider what the future holds for the study of quasars. Some people think we have discovered everything there is to know about them, but the reality is that each new generation of telescopes provides us with more data and discoveries. The search for new quasars and understanding their nature remains an active field of research. It's like a book that is still being written, full of surprises waiting for us as we look beyond. Demystifying quasars is a fascinating journey that invites us to question our preconceived ideas and explore the vast complexity of the universe. Each myth we debunk brings us one step closer to understanding these cosmic beacons. So, the next time you think of a quasar, remember that there is much more than meets the eye. In space, as in life, things are not always as they seem. Did you know that quasars are like cosmic lighthouses, illuminating the darkest corners of the universe? The search for new quasars is akin to an exciting hunt in the vast ocean of space. But why is it so important to find new quasars? The answer is simple. Each new discovery provides us with more information about the history, evolution, and nature of the universe. Astronomers have developed amazing tools and techniques to identify these distant objects. Imagine a lighthouse that emits light at a unique frequency. This is how scientists can distinguish a quasar from a star or a galaxy. Using powerful telescopes, they are able to analyze the light that reaches us, looking for patterns that reveal its true nature. But what about the technologies that make this search possible? Spectroscopy, for example, is one of the most important techniques. This tool allows scientists to break down the light from a quasar into its components. By doing so, they can identify chemical elements and determine the speed at which it is moving away. Can you imagine being able to measure the distance to a quasar that is billions of light years away from us, just through its light? It's a fascinating challenge that drives astronomers to keep exploring. However, not everything is so simple. The search for new quasars also involves facing obstacles. The universe is a huge place, and many of these bright beacons are hidden behind clouds of dust and gas. Scientists have to be ingenious, using observations at different wavelengths, from radio to X-rays, to see beyond these obstructions. Thus, they become true detectives of the cosmos, looking for clues that lead them to these mysterious objects. International collaboration plays a key role in this effort. Astronomers from around the world work together, sharing data and resources. Imagine a large network where each researcher contributes their knowledge and tools to achieve a common goal. This collaborative spirit has led to impressive discoveries and the identification of new quasars that were previously thought to be unreachable. In addition, artificial intelligence has begun to play a crucial role in the search for quasars. Programs designed to analyze large amounts of data can detect patterns that might go unnoticed to the human eye. What do these advances mean for the future? The possibility of discovering new quasars multiplies, and with it, our understanding of the universe. But what about the oldest quasars? The search is not limited to the brightest and closest. Scientists are interested in the quasars that existed in the early universe. These objects can give us clues about how the first galaxies and black holes formed. Each new quasar discovered is like a cosmic fossil that tells us about the past of the universe. Space missions are also contributing to this search. Telescopes orbiting the Earth can observe the sky without the interference of the atmosphere. This allows for a clearer and more detailed view, opening the door to the identification of new quasars. Space exploration is like a journey on a ship sailing through unknown waters, where each wave can reveal a new horizon. The research does not stop here. With each quasar that is discovered, new questions arise. What is their impact on the galaxies around them? How do they influence the formation of new stars? These questions keep astronomers in constant search for answers, turning each discovery into a new chapter in the history of the universe. The future of the quasar search is bright and full of possibilities. With new technologies in development and a growing interest in exploring the universe, we are likely to see an increase in the number of quasars identified. Each one of them is a window to a distant past, and by studying them, we not only learn about the cosmos, but also about our own existence. The search for quasars is a collective effort, driven by human curiosity and the desire to understand the universe. With each new finding, we get a little closer to unraveling the mysteries that surround us. Thus, quasars are not only objects of study, but also guides that illuminate the path to knowledge. As scientists continue their search, it's exciting to think about what the future holds. What new secrets will the quasars we have yet to find reveal? The exploration of the cosmos is an endless journey, and each quasar discovered is a milestone in our adventure towards the unknown. The story of quasars is far from over, and with each new discovery, the universe becomes a little more familiar and at the same time, even more astonishing. Quasars, those brilliant beacons of the universe, not only fascinate us with their dazzling light and immense energy, but they also play an intriguing role in the search for life beyond our planet. How is it possible that these distant and powerful entities have something to do with astrobiology? Let's explore this connection. First, it is essential to understand that quasars are massive black holes located at the heart of distant galaxies. When matter falls towards these black holes, it heats up and emits a large amount of energy in the form of light and radiation. This light travels through the vast cosmos and reaches us, allowing us to observe events that occurred billions of years ago. But why should we care about them in the search for life? The universe is a vast place, and although quasars are incredibly far away, their light offers us a unique window into the past. By studying the light from quasars, scientists can learn about the composition of the universe in its early stages. But in addition to that, clues can also be obtained about how galaxies form and evolve, and therefore the environments where life could arise. The relationship between quasars and galaxies is fascinating. In the early times of the universe, it is believed that quasars were more common and played a crucial role in the formation of galactic structures. What does this mean for astrobiology? It means that by understanding how quasars influence the creation of galaxies, we can also infer how and where the right conditions for life could have formed. The chemical elements that are created in star explosions and which are then dragged into black holes are fundamental. These elements are the same ones that form planets and therefore can be crucial for life. Can you imagine that life on Earth could have had its origins in the remnants of a star that was once part of a quasar? The radiation emitted by quasars also has implications for astrobiology. It is believed that this radiation can affect the evolution of planets and their atmospheres. On the one hand, it can destroy key molecules necessary for life, but on the other hand, it can also create new possibilities. Thus, the light from a quasar could be both a destroyer and a creator in the cosmic scenario. Furthermore, quasars can act as indicators of the distribution of dark matter in the universe. This matter, although it does not emit light and is difficult to detect, is fundamental in the formation of galaxies and therefore in the creation of environments that could harbour life. By studying how quasars interact with dark matter, scientists can get clues about where they might be more likely to find habitable planetary systems. The search for life in the universe is not just a matter of finding planets in the habitable zone of their stars. It also involves understanding the cosmic context in which those planets exist. What role did quasars play in supplying the necessary elements for life? How do they influence the stability of the galaxies where those planets could exist? Questions like these are fundamental in modern astrobiology. As we advance in our understanding of quasars, we also glimpse the possibility of finding life on exoplanets that orbit stars that, in some way, are influenced by these distant cosmic beacons. The relationship between the evolution of galaxies and the emergence of life is a field of study in full expansion, driven by the search for answers to questions that, until recently, seemed unreachable. In this vast ocean of possibilities, quasars stand as beacons that illuminate not only the past of the universe, but also the potential routes that life could have taken on other worlds. The light they emit, crossing billions of light years, tells us about the history of the cosmos, and at the same time invites us to reflect on our place in it. With each discovery about quasars, a door opens to new questions. Could there be forms of life that benefit from the extreme conditions around a quasar? How could the intense radiation affect the biology of organisms on planets close to these phenomena? Each answer generates even more curiosity and drives us to continue investigating. The study of quasars and their relationship with astrobiology is a perfect example of how scientists need to think in an interconnected way. It's not just about observing the cosmos, but understanding how each element, each star, and each black hole contribute to the great puzzle of existence. In the end, quasars are not just objects of study. They are part of a broader narrative that links all things in the universe. So the next time you look at the sky and think about those bright and distant points, remember that behind each quasar there is a story that could be related to the search for life, a reminder that we are all connected in this vast and mysterious cosmic network. The exploration of quasars not only helps us understand the universe, but it also brings us closer to the answers about our own existence in this immense space. In the vast ocean of the cosmos, quasars have captured the attention of astronomers and curious minds alike. But what's new in the exciting world of these beacons of the universe? Recently, scientists have made fascinating discoveries that are revolutionizing our understanding of these mysterious entities. For instance, did you know that some quasars are so far away that their light has traveled billions of years to reach us? This means that, by observing a quasar, we are not only looking at a distant star but a true journey into the past. One of the most astounding findings is the identification of new quasars in the early universe. Imagine a group of scientists looking for needles in a cosmic haystack, when suddenly they managed to detect a quasar that existed only 1 billion years after the Big Bang. This kind of discovery not only gives us an idea of what the first galaxies were like, but also allows us to understand how the first supermassive black holes that fuel quasars were formed. As more is explored about these distant quasars, secrets about the evolution of the universe and its structure are revealed. Technology has also taken a big leap forward in quasar research. With more powerful telescopes than ever, like the James Webb Space Telescope, astronomers are managing to observe details in the light of quasars that were previously invisible. Can you imagine being able to break down the light of a quasar to identify the chemical elements that compose it? This is exactly what is being done. By studying the light emitted by these objects, scientists can deduce not only their composition, but also how they interact with their environment. It's like having a window to a cosmic laboratory where new elements are being forged. An intriguing aspect of recent research is the variability of quasar brightness. Sometimes they shine intensely, and at other times their light weakens. What is causing these changes? Some researchers believe that this may be related to the activity of the supermassive black holes that feed them. When a black hole swallows matter, it can release huge amounts of energy that manifest as an increase in brightness. This phenomenon is not only fascinating, but also provides clues about the internal dynamics of these enigmatic objects. On the other side of the spectrum, it has been found that quasars may be related to dark matter, that mysterious substance that makes up much of the universe. How are they related? Some studies suggest that quasars can act as beacons that illuminate the distribution of dark matter in their surroundings. By observing how the light from a quasar bends when passing near a concentration of dark matter, astronomers can map its presence. This innovative approach is helping to solve one of the great mysteries of cosmology. Furthermore, quasars are being used as tools to measure the expansion of the universe. By observing their light and spectral features, scientists can calculate the speed at which they are moving away from us. This is similar to listening to the sound of a departing train. As the sound changes, you can deduce how fast it is moving. This type of measurement is fundamental to understand how the universe is expanding and what the implications are for its future. A fascinating discovery has been the relationship between quasars and galaxy formation. It has been observed that quasars can influence the growth of new stars in their surroundings. By releasing huge amounts of energy, they can heat the surrounding gas, which can trigger the formation of new stars. This process is like igniting a spark in a workshop full of materials ready to be transformed. With each new discovery, a more complete picture of how quasars and galaxies coexist and evolve is being built. Recent studies have also begun to explore the role of quasars in astrobiology. It's amazing to think that these distant objects could have an impact on the search for life on other planets. The intense radiation from a quasar can affect the atmospheric chemistry of planets in its vicinity, which leads to the question, what effects could it have on the possibility of life? This intersection between quasars and astrobiology is a new and exciting field that is beginning to bloom. Of course, not everything is positive. The intense radiation from quasars can be harmful to life as we know it. So, while scientists look for quasars that could illuminate the path to new life, they must also consider the consequences of their influence. Does this mean that some worlds are destined to be inhospitable? due to proximity to a quasar? These questions are what fuel researchers' curiosity. With each new discovery, myths and prejudices about what quasars are and their role in the universe are being dismantled. As astronomers continue their search, they are realizing that these objects are not just sources of distant light, but key pieces in the puzzle of cosmology. The exploration of quasars allows us to see beyond our own solar system and better understand the vast universe that surrounds us. So the next time you look up at the sky and see the stars, remember that some of them are actually quasars, sending light that has traveled billions of years to reach our eyes. On their journey, they tell us stories about the past, present, and future of the universe. On the horizon of astronomical research, quasars continue to be beacons that guide us in the search for cosmic knowledge. Quasars are, without a doubt, one of the most impressive phenomena in the universe. With each advance in our understanding, new questions and possibilities open up. What else will they reveal in the future? Human curiosity is insatiable, and as long as we keep looking up at the sky, quasars will continue to be a fascinating topic of exploration and discovery. Have you ever stopped to think about the vastness of the universe and how quasars become our guides in this immense darkness? These distant cosmic beacons not only illuminate the darkest corners of space, but also offer us a fascinating glimpse into the very history of the cosmos. In this conclusion, we will reflect on the importance of quasars in our understanding of the universe and how they help us unravel its mysteries. Quasars are like lighthouses sending us light signals through time and space. Imagine that every time we observe a quasar, we are looking back in time to an era when the universe was very different from what we know today. Isn't it amazing to think that the light from a quasar may have originated billions of years ago, when galaxies were just beginning to form? These objects allow us not only to see the past, but also to understand how the universe has evolved over the millennia. Have you ever wondered how quasars can be so powerful? The answer lies in the supermassive black holes at their centers. These black holes are like giant devourers of matter, absorbing gas and dust around them, generating immense energy. This energy is released in the form of light and other radiations, making quasars the brightest objects in the universe. Thus, quasars are not only beacons, but also sources of energy that light the way for astronomers in their quest for knowledge. The light emitted by quasars is a treasure for science. Each photon that travels towards us carries with it information about its origin, its composition, and even the environment in which it was formed. Thanks to this light, astronomers can unravel the secrets of dark matter, the expansion of the universe, and the evolution of galaxies. The light from a quasar is like a letter from the past, written in a language we are still learning to read. Quasars are not only important for understanding the past, but also challenge us to think about the future. As astronomers discover new quasars, a new chapter in our understanding of the universe opens. Each new finding raises intriguing questions. What other secrets does the cosmos hide? Could quasars offer us clues about the existence of life elsewhere? The possibilities are endless. Furthermore, the relationship between quasars and dark matter adds another layer of mystery. How do these cosmic beacons influence the distribution of matter in the universe? Dark matter makes up a large part of the cosmos, and understanding its interaction with quasars is crucial to developing a more complete model of the universe. This is a cosmic puzzle that we still have to solve. The variability of quasars is another fascinating aspect. Why are some brighter at certain times and others not? This behavior can reveal information about their internal structure and the dynamics of the black holes that feed them. Each quasar has its own personality, and each flash of light tells a unique story. Quasars are also valuable tools in cosmology. They help us measure distances in the universe and better understand its expansion. The relationship between the light from quasars and the distance they have traveled is one of the keys to deciphering the rate at which the universe is expanding. This is essential for understanding the evolution of the cosmos and the final destination it might be heading towards. Beyond their scientific relevance, quasars invite us to reflect on our place in the universe. What does it mean to be part of this vast cosmos full of mysteries and wonders? Quasars remind us that despite our small scale, we are part of something much larger. Each discovery in astronomy, each new quasar catalogued, is one more step in our search for answers. Finally, quasars are a symbol of curiosity and exploration. They show us that despite the distances and difficulties, there is always more to discover. The search for new quasars and the investigation of their properties push us to continue exploring the universe, challenging our understanding and expanding our horizons. In conclusion, quasars are more than simple points of light in the sky. They are beacons that illuminate our path to knowledge. Through them, we can explore the past, unravel the nature of the universe, and perhaps take one more step towards understanding our own place in this vast and mysterious cosmos. So, as we gaze at the starry sky, let's remember that each quasar is a window to infinity, inviting us to discover what lies beyond.